Okay, going into week 5 of term 1, we're just going to run through some further derivatives of sine and cos. So this video will give you a fairly wide range of the types of problems you can expect to encounter as we go through the derivatives of sine and cos functions. So just a quick reminder of the derivatives of sine and cos. Derivative of sine x equals cos x, and the derivative of cos x equals negative sine x. So once again, you do need to remember this, and it should be becoming fairly common knowledge now for all of you. So we can use the chain rule, product rule, quotient rule, and they still apply to sine and cos. And just when we are doing the derivatives of sine and cos, we need to make sure we're using radians. Okay, the rules only apply if things are in radians. So we're going to look at some today where we have degrees, and we're going to convert those degrees into radians before we can perform derivatives. So in this first example, if fx equals cos 7x minus 8, we want to find the derivative of fx. So we know the derivative of cos x, but we don't know 7x minus 8. So we're going to use the chain rule on this one. And we're going to let u equal 7x minus 8, and the derivative of u with respect to x will just be 7. So as we have here, fu equals cos u, derivative of fu equals negative sine u. So then the derivative of fx equals the derivative of u, which was 7, times the derivative of fu. That's just the chain rule there. That's all we're using. So we substitute 7 and sine u. And once we substitute u equals 7x minus 8, we find the derivative is negative 7 sine 7x minus 8. Okay, so whenever you see a bracket like that, when it's not just the x, we need to use the chain rule. In this one, this is one I mentioned earlier, we've got a degree. So this function uses degrees. So like I said, when we're doing derivatives, we need to convert those degrees into a radian value. So the first step is to convert the 4 theta degrees into radians. And you should remember from last year, to convert from degrees to radians, we multiply by pi over 180 degrees. So when we do that, the 4 can get cancelled, and we're left with pi theta over 45 degrees. So that is radians. So put that back into our original equation. We've got y equals sine 4 theta over 45 degrees. And now it's just apply your derivatives laws as normal. So we want to, again, you could use the chain rule here. I'll kind of jump the step here, but if you let u equal pi theta over 45, apply your chain rule, you'll find out that this is what the derivative works out to be. Now we probably should, because a question was given to us in degrees, we should convert what's inside the brackets here from radians back into degrees. So that would be multiplying by 180 degrees. 180 divided by pi. So derivatives of tan x. Tan x equals sine x divided by cos x. That's just a trigonometric property. That's probably worth remembering. So here we've got a quotient, so we can use the quotient rule. uv, v derivative of u minus derivative of v times u over v squared. We let u equal sine x, and so the derivative is going to be cos x, and v equal cos x, so the derivative of v will be negative sine x. And then just simply put that into our quotient rule. Cos times cos minus sine x times negative sine x divided by cos x squared. That's just using substitution and using the quotient rule. So this can simplify down. Cos x squared plus sine x squared divided by cos x squared. looking at differentiating sine squared x, when we write it with the 2 or the power before the x, it's the same as writing sine x squared cos x cubed, for example. You just want to make sure you make that distinction between sine x squared, so sine x in brackets squared, and sine brackets x squared. Okay, there's two different things. You just got to be careful with your brackets and your powers. So we want to find the derivative of sine x squared. So again, we're going to use the chain rule. We let u equal sine x, so we're really going to find the derivative of u squared. So that's going to be 2u times cos x. So the cos x is the derivative of u, and that's just using the chain rule. So that simplifies down to 2 sine x cos x. Okay. Again, if it's gone too fast for you, just step through that. We're just using the chain rule, and I've just cut out a few steps to speed up the process, but we're just using the chain rule. This is a slightly more difficult one. Here we've got it's cos x, cos brackets x squared. I probably should have put brackets there just to clarify that a bit. But unless you see brackets around the cos and the x, you can just assume that the x is the only thing being squared here. And so again, we're just going to use the chain rule. Let u equal x squared. So we are left with 3 divided by 4 cos u. So once we've substituted, we're going to let v equal cos u. So this is a double chain rule, which is okay, we can do that. So we just got another substitution here. So we've let v equal cos u. So what we have now is 3 divided by 4 times v, and we can bring that v up to the top by making that a negative index. That negative shouldn't be there, that was a mistake. So ignore that negative there. Okay, so I'm looking at this. Again, ignore that negative. We can just work backwards using a series of chain rules. So this is just multiple chain rules being applied. We want to get to dy dx. And if we multiply these 3 different stages, the dv's will cancel, the du's will cancel, and we'll be left with dy over dx. So again, that's what we're going to do. We're going to substitute these in. Again, ignore that negative. I don't think it should. Now it should be there, sorry. The negative's fine now. So we've worked out the derivative of dy dv. So we've just worked out the derivative of this function. So that was a positive. The negative comes down. Subtract 1 from the index. And we get minus 3v minus 2 divided by 4 times derivative of v with respect to u. So here we let v equal cos u, the derivative is negative sine u, and the derivative of u with respect to x, so back up here, and that was just going to be 2x. So we've multiplied each step in that chain rule, multiplied by each other, and once we substitute back in again, it's just substituting the u's and the v's in as we go through and simplifying the expression. We'll find out that our dy dx comes out to be this value here. Obviously we want to get rid of that negative index, so we can bring that bracket, what's in that bracket, down and simplify it that way so we have nice positive indexes. So as we multiply all that together and simplify it, we get 3x sine x squared divided by 2 brackets cos x squared, close brackets, squared. Okay, so there's a number of, or a range of derivative problems that you can expect to encounter. Most of those are probably C and B level questions, maybe touching This last one here is probably touching on an A level due to the number of steps involved. So your A level questions, you can expect to have multiple steps involved, but they don't get too tricky. And just got to remember quotient rule, product rule, and most importantly the chain rule all apply, and it's just breaking it down and simplifying it as much as you can. Alright, thanks for that. We'll move on to the next topic.